Hello. So today I'm going to talk about some basic about oxidation reduction reaction. So we all know that we are going to just learn this oxidation and reduction for a long time. Okay. So I'll try to give some new flavor, but I don't know how whether I could or not, but I'll try. So before talking about oxidation and reduction reaction, I want to talk about the use of oxidation and reduction reaction or application of oxidation reduction reaction. If we consider about the branches of organic chemistry or any chemistry, so it could be the inorganic chemistry, it could be our organic chemistry, it could be biological chemistry. Each and every part basically need the oxidation reduction reaction, and the addition of oxidation or removal of oxygen or removal of oxygen is really important part. So if we look at the classical concept of oxidation and reduction, basically I prefer to teach oxidation and reduction in a simple way that either you will remember the oxidation or you will remember the reduction. If we consider that if I write only for oxidation, so oxidation basically depend on addition of oxygen. The first point we came here, addition of oxygen. So addition of oxygen like carbon plus oxygen, carbon dioxide. Okay, this is oxidation reaction. So oxygen is electronegative element. Now second point will come that addition of any electronegative atom. Then if we consider that here chlorine is the electronegative atom and chlorine added with sodium, so sodium chloride. So this is oxidation of sodium. Now, if addition of electronegative atom is oxidation, then we can say that removal of electropositive element is oxidation. Removal of electropositive, I writing just a short one. Okay, electropositive element is a oxidation reaction. Then we can say that zinc plus copper sulfate, then it will form the zinc sulfate plus copper. So we can say that zinc sulfate copper is replaced, that means electropositive element is replaced, so this is oxidation. Again, at last, if removal of electropositive element, then we can say removal of hydrogen is also a oxidation. Removal of hydrogen. Now removal of hydrogen, that means we need to remove hydrogen, like we can say sodium plus HCl, then sodium chloride plus hydrogen. Hydrogen is removed. This is the classical concept. Addition of oxygen, addition of any electronegative element, removal of electropositive element, removal of hydrogen. Because if you add electronegative element, it is oxidation, then must be electropositive element addition should be oxidation. Removal of electropositive element should be oxidation. Removal of hydrogen should be oxidation. Now, if we consider about the electronic concept is just easy. Removal of removal of hydrogen, then according to electronic concept, removal of electron. Removal of electron. That means sodium, when donate one electron, it get oxidized. Okay. So now the concept is that you can remember only the oxidation, then reduction will become easily. Like if we consider that addition of oxygen is oxidation, now I will convert it to reduction. Okay, I will consider it as a reduction. Okay, reduction. If we say this is a reduction, then this addition should be replaced. This addition should be replaced by removal. That means Removal of oxygen is a reduction, and this addition should be again removal. That means removal of any electronegative element. All the removal will be addition. That means addition of electropositive element, and this one will be also addition. So addition of hydrogen, and this one will also be addition. Now you see, if you can remember oxidation only, then it is easy to remember the reduction. Okay, then the reactions will be changed. Okay, reactions will be changed. Will change, the changed reaction will be like so removal of oxygen, then we can say Fe2O3 plus carbon, then iron plus carbon monoxide or carbon dioxide. So that means this iron get reduced because oxygen is removed. Okay, and then H2S plus Cl2, then HCl plus sulfur. So from sulfur, sulfur is removed from hydrogen here. Okay, if sulfur is removed from hydrogen, that means electronegative element replacement, removal of electronegative element. Then if we consider about that, remove addition of electropositive element, then we can consider the same reaction like zinc sulfate, zinc plus copper sulfate. So then zinc sulfate plus copper. Now, if we consider about sulfate, sulfate is attached with zinc. Zinc is electropositive element, so sulfate get reduced. Now, addition of hydrogen, it's easy. Hydrogen plus chlorine, hydrogen chloride, and then addition of electron according to electronic concept. Just chlorine plus electron, chloride ion. So easy. Just you need to oppose. So if we say the oxidation, then just make the addition to removal and removal to addition. If we say about the reduction, then remove this one to addition and this one to removal. That's it. So the concept is same, just you need to add somewhere and you need to reduce somewhere or remove somewhere. So this is the basic concept of oxidation and reduction reaction we usually use in our everyday life deeply. That what happened during oxidation and reduction reaction. Now, if we consider one reaction that where oxidation reduction is occurring, like redox reaction, we say this is a redox reaction. Okay, so now if we consider that this is a reaction Fe2O3 plus carbon, then we get Fe plus carbon dioxide. Now, if we consider about this reaction, first we look at the iron oxide. So, from this iron oxide, oxygen is removed. That means here oxygen is removed. Okay. So, removal of oxygen means that means it get reduced. Removal of oxygen, so reduced. Now, what happened to carbon? What happened to carbon? Carbon basically gain the oxygen. That means addition of oxygen. Addition of oxygen. So if addition of oxygen, that means carbon get oxidized. Now look at the board. So iron oxide, it basically get reduced by removal of oxygen. Now, if oxygen need to be removed from iron oxide, then somebody need to accept that oxygen, or if carbon want to accept the oxygen, then it must have to remove oxygen from someone. Now, because of that, always if there is oxidation reaction, then there should be a reduction reaction. If there is a reduction reaction, then there should be a oxidation reduction. As a result, we say that oxidation reduction reaction always takes place simultaneously. Now, again, if this one is get reduced, and by whom? Carbon. Then carbon is a reducing agent. That means carbon is a reducing agent. Those who has the ability to reduce someone, those who has the ability to reduce someone is known as reducing agent. Again, carbon get oxidized. Who basically responsible for this oxidation? This one. So this one we can say this is a reducing oxidizing agent. Now, if you look, the oxidizing agent get reduced to oxidize carbon. The oxidizing agent get reduced to oxidize carbon. Okay. The reducing agent get oxidized to reduce. So, if we look at there, a oxidizing agent, a oxidizing agent oxidize someone and itself get reduced. So a oxidizing agent should oxidize someone and then itself get reduced. So we can say oxidizing agent get reduced to oxidize someone. Again, reducing agent oxidize someone, then itself get, sorry, oxidizing agent get reduced and oxidize someone. Reducing agent get oxidized and reduced somebody. Oxidizing agent get reduced and oxidize someone. Reducing agent get oxidized and reduce somebody. That means we can say red oxy, that means reducing agent will get oxidized and oxy red, that means oxidizing agent get reduced. So it is a common that oxidizing agent will get reduced and reducing agent will get oxidized in any chemical reaction. And most of the time you see that if there is oxidation reaction, if there is a reduction reaction, then there should have oxidation reaction, and if there is oxidation reaction, then there should have a reduction reaction. As a result, we call that oxidation reduction reaction takes place simultaneously. Now, how to recognize that which one is oxidizing agent and which one is reducing agent? Basically, the common technique is if you find out something with a higher hydrogen number, then this is a reducing agent, and higher oxygen number, this is a oxidizing agent. And most of the metals are reducing agent, and most of the non-metals are oxidizing agent. This is the common concept. We will learn later that how we can definitely know. Now, if we consider about this is we discuss about the classical concept. Now, if we consider about another reaction like sodium provide one electron and convert it to sodium ion, and chlorine accept this electron and convert it to chloride ion. Now, addition of removal of electron is oxidation. Now we can say sodium get oxidized. Again, chlorine is reduced. If chlorine reduced, then chlorine is a oxidizing agent, and sodium is a reducing agent. So we can say sodium is a reducing agent here. So again, you can say reducing agent get oxidized, oxidizing agent get reduced. Now, from this classical electronic concept, we can also say that if sodium need to donate a electron, somebody must have to accept this electron. If there is somebody who has the ability to accept this electron, then we can say that sodium is get oxidized. Without this electron, without this donation of the electron, chlorine cannot get reduced. Again, if we say that without the acceptance of this electron by chlorine, sodium cannot get oxidized. So to oxidize sodium, chlorine is necessary. Again, to reduce chlorine, sodium is necessary. So that means we can say that this process basically depend on one another. It cannot be happen independently. So as a result, we should say that oxidation reduction reaction takes place simultaneously. That means one should lag behind another one. If there is oxidation, then there will be a reduction. If there is a reduction, then there will be oxidation. Without this one, we cannot say that oxidation occur silently, or only one oxidation is occurring, only reduction is occurring. That means they should come together, and as a result we call that oxidation reduction takes place simultaneously. Okay, now when you see any reaction, how you basically can understand which one is oxidizing agent and which one is reducing agent. So one of the way that you can look at that who donate electron and who accept electron, and another one is you will find out that who, like in the reactant side, if somebody has two oxygen and it get actually like someone have some oxygen atom, so this oxygen atom is removed, then I can say that iron get reduced. Someone have no oxygen atom, it is attached with another oxygen atom after the reaction, then I can say this is a oxidized. Okay, but for any common reaction, how we can determine? We basically depend on the oxidation number. We depend on the concept of oxidation number. Now, what is oxidation number? Oxidation number is basically very easy, that either the atom accept an electron or the atom donate an electron. If the atom accept an electron, then its oxidation number will be negative. If any atom donate an electron, its oxidation number will be positive usually. Okay, like if sodium donate one electron, so there will be a positive oxidation number. If calcium donate two electron, then there will be a 2 plus positive oxidation number. If aluminium donate 3 electron, and there will be a 3 plus oxidation number. 3 electrons, so 3 plus. Okay. On the other hand, if chlorine accept this electron, it converted to negative oxidation number. If oxygen accept this 2 electron, then it converted to 2 minus. If like nitrogen accept this 3 electron, then it converted to N3 minus. This is the oxidation number. Okay. Now there either always is this is true, that always it will be positive, that means oxidation number electron donation means positive, it will become negative. No, there is some exception, so we will tell it later. Now there is some concept, there is some rule to determine the oxidation state of any element in any compound. Okay, now if we consider the rules, if we think about the rules, First of all, always the oxidation number of atom is 0. That means if we have sodium, if we have chlorine, if we have magnesium, their oxidation number is always 0. Okay, and then if there is any oxidation number of the ion, if we consider this is an ion like aluminum 3 plus, then oxidation number is just equal to its charge, or oxygen 2 minus, then oxidation number of this one is just it equal to its charge. Okay, and the oxidation number of group 1 element, group 1, that means sodium, like lithium, sodium, potassium, rubidium, all of their oxidation number is 1 usually, and the halogen group is usually, for group 7a, it is usually -1. Okay, for oxygen, the oxidation number for oxygen usually the oxidation number is -2. In case of peroxide, it is -1. In case of suboxide, it is -half. Okay, now in case of superoxide, it is -half. Okay, now what is the oxidation state of hydrogen? If hydrogen is attached with any element which is non-metal and electronegativity is higher than hydrogen, then its oxidation number is always +1. So that means if hydrogen attached with carbon, then there will be +1. Now, if hydrogen attached with sodium, that means more electron positive element than hydrogen, then it is -1. So if we summarize that, we have some rule that the ions have the oxidation number equal to ionic their charge, all of the normal condition. If magnesium is in normal condition, chlorine is in normal condition, sodium is in normal condition, then their oxidation state is 0. If oxygen, then its oxidation number is -2. For peroxide, it is -1. For superoxide, it is -half. For group 1 elements, it is +1. For group 2 elements, it's +2. For group 3 elements, usually it's +3. For group 7a, that means halogen group, it is always -1. Okay. Now, in case of hydrogen, if it is attached with any electronegative, any element which is more than electronegative than hydrogen, then it is +1, and any element which is less electronegative than hydrogen, then it is -1. Okay, and the most of the important case is that if we add all the oxidation number of any, if we add all the oxidation number of any compound, like there is K2Cr2O7, if we add all the oxidation number, that means oxidation number of K plus oxidation number of Cr plus oxidation number of oxygen, then total will be 0. The addition of all of the oxidation number of any compound is equal to 0. Now, if we consider, we want to find out the oxidation number of chromium. Like for potassium, it is group 1 element, we know that +1 into 2. For chromium, we don't know what is its. So, we suppose the oxidation number of chromium is X, so 2X. And then oxygen, it is -2, usually into how many oxygen atoms? 7 oxygen atoms. Now we can write +2 plus 2x minus 14 equal to 0. Now we can write plus 2x, or we can 2x minus 12 equal to 0, or x equal to 2x equal to plus 12 if we send it this side. Therefore x equal to, we can say, plus 12 divided by 2. So our, therefore x equal to will be plus 6, 12 divided by 2, So oxidation number of chromium will be plus 6. Okay, so by this way we can determine the oxidation number of any compound. Okay, now if there is ion, suppose there is ion MnO4 minus. Now how to find out its oxidation number? Easy. Like we said, the oxidation number of the ion is equal to the charge. Then we can say the oxidation number of manganese plus minus 2 oxidation number of oxygen into 4, it should be equal to the charge of the ion, that means minus 1. So in case of compound it is 0, in case of ion it is equal to minus 1. Then x minus 8 equal to minus 1. So we can say x equal to minus 1 plus 8 equal to plus 7. So here manganese is plus 7 state. That means manganese donates 7 electron to form this bond. Okay. So by this way we can determine what is the oxidation number of any compound. Now if we consider a reaction, how we can utilize this oxidation number to understand which one is oxidation and which one is reduction, and which one is basically get oxidized and which one is basically get reduced. Now if we consider the previous reaction, just I'm not giving a lot of reaction, just consider about this reaction, FeCl2 plus Cl2, then you have FeCl3 plus, okay, nothing. Okay, now what is the oxidation number of iron here? Halogen group, it is minus, halogen group is minus 1. So minus 1 into 2, minus 2. To neutralize minus 2 we need my plus 2. So minus 2, the overall charge is 0. Okay, what about this one? In atomic state always 0. Now what is happening here? What is the oxidation number of iron here? Plus 3. What is the oxidation number of chlorine? Minus 1. So from chlorine 0 it converted to minus 1. From chlorine iron 2 plus it converted to iron 3 plus. That means we can say for iron positive oxidation number increases, positive oxidation number increase, and for chlorine we can say negative oxidation number, negative oxidation number increase. So positive oxidation number increase, if any reaction positive oxidation number if increased, then the reactant for which positive oxidation number is increased, it get oxidized. For any reactant for which negative oxidation number is increased, then it get reduced. So that means if we have the concept of oxidation number, then it is easy to determine also the oxidizing agent and reducing agent. So who get oxidized, he should be reducing agent. Who get reduced, he should be oxidizing agent, just vice versa. Okay, now if positive oxidation number increase means oxidation, that means negative oxidation number, if we say negative oxidation number decrease should be the oxidation. Okay, again negative oxidation number increase means reduction, so positive oxidation number, positive oxidation number decrease means reduction. That means in any reaction, it is not mandatory to have this type of 0 to -1. If plus 3 to plus 2, then it is also a reduction process, plus 3 to plus 2. Okay, or -1 to 0, it is also a oxidation process. Okay, so by this one we can determine the oxidizing agent or the reducing agent from any kind of reaction. Okay, now based on, basically, if there is this type of reaction and there is a lot of reactant in the solution, now how you will determine that which ion basically get oxidized or which ion get reduced? This is determined by the EMF series. There is the EMF series. I will teach it in the like electrochemistry chapter. When we learn about the cells, electrochemical cells and others, we will learn it more accurately. So then we can find out that there is a series. Its name is electrochemical series. Now I am giving you some of the example where there is a lot of reaction is given here. You need to find out which one is oxidizing agent and which one is reducing agent. Like if I solve one of them, just one of them for you, like in a reaction SN4 plus and chromium 2 plus react with each other to form SN2 plus and chromium 3 plus. Now, which one is oxidizing agent and which one is reducing agent? If you look at the positive oxidation number of this species is reduced or increased? It is reduced. If reduction of positive oxidation number, then we know that addition of electron. If addition of electron, then it is get reduced. Now, if we consider about this species, positive oxidation number is increased. So positive oxidation number increase mean oxidation. Just in the last case we discussed about that. So by this way, you can practice from this slide that whether which one is oxidizing agent and which one is reducing agent, and then it will help you to make your understanding more good, and it will be helpful for you. Now there is a common thing we usually use for titrimetric analysis of any ingredient for our pharmaceutical analysis or any other analysis courses. We use this concept to find out the how much ion is used to oxidize someone or how much ion is used to oxidize reduce someone, and for this we need the balancing of oxidation and reduction reaction. So here the total how to say, the theoretical rules of balancing oxidation reduction reaction is given in the screen. You can see them, you can read them, and you can memorize them, but I will teach you a simple method how to do this process. Now if we consider a reaction, a single reaction where it is a acidic condition, and the reaction said that ferrous sulfate react with chromium potassium dichromate and convert it to chromium 3 plus and iron 3 plus ion, and it is said that it is a acidic condition. Now you need to find out the balancing equation for this reaction. Now, whenever you see this type of reaction, whenever you see this type of equation, then first of all, our concern should be which one is oxidizing agent and which one is reducing agent. Now, if we look at the initial and final stage, iron was 2 plus, it is converted to 3 plus. Chromium, here what is the chromium? So 7 into 2 minus 14, minus 14 equal to minus 2. Then 14 when go this side, so minus 14, 2x for dichromate, 2x plus minus 14 equal to minus 2. So if minus 14 goes there, then it is plus 14, then it is plus 12, so x equal to plus 6. Okay, so chromium is here plus 6. You know how to make it. Okay, so now if chromium is plus 6, then chromium plus 6 converted to chromium 3 plus. Okay, now if we think chromium plus 6 to chromium 3 plus, that means we need addition of 3 electron. So it is reduced. So who get reduced? Oxidizing agent. Now for this one, it actually donate 1 electron. So this is a oxidation process, and this is a reducing agent. Now we will write down two half reaction. One for reduction half reaction, another one is oxidation half reaction. Now for which I will write the reduction half reaction for this one, because here chromium reduced to chromium 3 plus. So this is basically the way ingredient or the reactant for which we will write down the reduction half reaction, and for this one we will write down the oxidation half reaction. So from this one, now if I write the reducing half reaction, at first I prefer to write the reduction half reaction. So reduction half reaction, if we consider about reduction half reaction, so you will see that Cr2O7 2 minus, so it will accept one chromium need 3 electron, plus 6 to plus 3, so 2 chromium need 6 electron. Then it will convert it to 2 Cr3 plus, because here is 2. Okay, and the surprisingly, always you need remember that in the oxidation reaction balancing equation, if there is oxygen like that, it will completely convert it to equal amount of water molecule. This oxygen converted to water molecule. So there is 7 oxygen, 7 water molecule. Now, which, so there was 2 Cr3 plus plus 7H2O. Now you can see 14 hydrogen is extra here. Okay, I just keep 14H plus. So now this two side is balanced. If we consider about electronically, if we consider about chemically. Okay. Now if we say that oxidation half reaction, no, for oxidation half reaction, iron 2 plus converted to iron 3 plus and give only 1 electron. Now if it only 1 electron is donating, but you need 6 electron to balance this one, so we can multiply this oxidation half reaction by 6. Now we have the equal amount of electron, because we know that during the oxidation reduction reaction, the oxidation half reaction should provide equal amount of electron necessary for reduction half reaction. If it is impossible for it to donate similar amount of electron, then it is impossible to continue the reaction. So that means this 6 electron basically help this dichromate to be reduced, and the equal number of electron is ensured. So now we will see how we can balance this equation. Okay, if we consider that this reduction oxidation half reaction should reduce this reduction half reaction, the number of electrons should be same. As a result, we multiply this one by 6. Okay, now consider that if we add these two equations, then what will happen? Addition of these two electron, then there will be 6 iron plus, and here will be 6 Fe3 plus 6 electron. Now this 6 electron and 6 electron, so equal. So Cr2O7 2 minus plus 6 iron 2 plus 14 is plus is converted to 2Cr 3 plus, and then 6 Fe3 plus 7 H2O. Okay, so this is the balanced equation. Now sometimes you are asked that provide opposite ions to this ion to complete the reaction. Now if they are telling that provide opposite ion, now you have that this is acidic condition reaction, and I prefer to give the same acid which contained here as a salt. Like if it is sulfate, then I prefer to give sulfuric acid. If it is nitrate, I prefer to give nitric acid. If it is chloride, I prefer to give hydrochloric acid. Now as it is a sulfate, and if we look at our equation, dichromate plus iron plus hydrogen ion plus chromium, and then if we make it like that, so dichromate we can convert it to potassium dichromate. Okay, 6 Fe, so 6 FeSO4, then 14 H plus, then what will be our product? Cr2SO4 3. So 14 H plus we can write down it 7 H2SO4. 14 remains same. I said as there is a sulfate, I will give the sulfuric acid. Okay, plus, so Fe2SO4 3. So there is 2 chromium, but here this is 2 iron, so it should be 3. 3 into 2, 6. 6 remains same. Okay, then you have this potassium, then K2SO4. So K2SO4 plus we have 7H2O. Just write 7H2O. Now find out whether the ions are same. There is 2 potassium, 2 potassium, 2 chromium, 2 chromium. Okay, 7 oxygen, 7 oxygen, 6 iron, 6 iron, 6 sulfate, and 7, 13 sulfate total. Okay, so there is 3 into 3 9, 3 and 9 12, and 1 13. Okay, and then hydrogen is 14, and there is 14. So all of the ions you can find out here is equal. So we can say this is a balanced equation. And from this balanced equation, if it is a tachymetric analysis, then we can realize 1 mole of dichromate always react with 6 mole of ferrous sulfate. Now, if we have any question, if you have any mathematical problem which said you to determine how many moles of ferrous sulfate necessary to neutralize 1 mole of potassium dichromate, it is easy to find out 6 moles equivalent to 1 mole. Then if it is tell that we have 10 gram of iron sulfate, how much amount of dichromate is necessary? Then just what is the molarity of 10 gram of sulfuric acid, you can remember fresh sulfate, and then just equivalent this and you will find out the result of the reaction. This is basically very easy and you can do it by yourself, and this is just a simple method. At first go for the reduction of reaction, then oxidation of reaction, then find out whether the number of electron you need in the reduction of reaction, either it is equal to the oxidation of reaction or not. If it is lower, then multiply any of the equation to make it equal number of electron. Then just if number of electron is equal now for the oxidation of reaction, that means how many electron is needed here and how many electron produced here. If it is equal, then just add them together and then you just provide the opposite ion to them. This is the balancing of oxidation reduction reaction. Now I will give you assignment for some of the reaction. A lot of reaction is there and you need to just compare it, you need to complete it and practice it by yourself. Then you can find out it is really easy to balance oxidation reduction reaction, and after balancing of the oxidation reduction reaction you will find out that it is really enjoyable for you. You can find out any kind of problem, you can solve now any kind of problem and you have the confidence. Okay, now so the electrochemical series, we said that we will discuss it later, and according to the electrochemical series we can understand a lot of things, that how the reduction potential is decreasing, oxidation potential is increasing, which metal will act as oxidizing agent, which metal is act as a reducing agent in the same solution they are present, or which one is our anode, which one is cathode, and which electrode should be anode, which electrode should be cathode in the presence of different type of metallic ion, or we can consider about non-metals too. Now this is basically will help you to understand the oxidation reduction reaction, and in the next class we will talk about the electrochemical series and use of electrochemical series and the reduction potential and oxidation potential of the series in chemistry, and to get the insight of the electrochemical cells and not the electroanalytical cells, to get inside the electrochemical cells, and it will determine by the electropositivity or the electronegativity of the elements, and then we can realize that how oxidation reduction reaction basically govern over the electrochemistry too. So I said it is important for the biological chemistry, it is important for the organic chemistry, it is important for the inorganic chemistry, it is also important for the electrochemistry. Okay, so thank you. I hope this video will help you and you can learn something easily in easy method. I tried my best to give you the way, but you need to find out your way also, and you need to consider. And I am not a very good teacher, so not actually I'm not a very good student, so I always try to remember one, either oxidation or reduction. So it depends on you which one you will remember. Now if you can remember reduction, then go for reduction, and just remember that reduction is just oxidation is opposite to the reaction, and in case of oxidation just remember the oxidation and then go for the reduction is opposite to this one. Okay, thank you, have a good day.